3 in the afternoon, so I don't know if I have to say Kalimera or Kalispera.
Kalispera.
We are ready for Kalispera. So Kalispera, everybody. I'm Cristiano SENO. I am a mechanical engineer involved in the air conditioning business on the air side especially. So air handling units, rooftops and fan coils. Today I would like to give you a short review of this new norm, which is the eco-design norm concerning the air handling units, as it is changing drastically the scenario in the air conditioning field in the whole the European market. The Commission regulation 1253 starts from year 2014. It is in the framework, the general framework of the Community Directive 125, with the aim, the idea of reducing the electrical consumption of all the products involved in the air conditioning field. So everything used in the air conditioning field should give better performances, or at least the same performances, but using less electrical energy. This is the idea of the general framework. Then, in the general framework of this directive, the European Community gave different regulations, each one controlling the design of each single project. So in this case we are discussing about air handling units, but there are ERP eco-design regulations dedicated also to other different products. This regulation, as you see, defines the technical characteristics, formulas, specifications, things that could not be used anymore when designing the air handling units, in order to guide the job of the air handling unit producers from one side, but also the job of the consultants and designers on the other side. They give some definitions. It's quite small, but I try to summarize. There's a split between residential and non-residential air handling units. Residential air handling units have air flows lower than 250 cubic meters per hour, so we talk about very, very small air flows, or air flows between 250 and 1,000 cubic meter, but the producer should clearly declare these units are for residential application. So if they say between 250 and 1,000, these units are for residential application, these units are out of the range of the normative we are discussing now. All the other air handling units should be considered in the framework of this technical regulation given by the European Community. Then there are some, let's say, exceptions. We will discuss about these exceptions looking to the different definitions given by the regulation, but more or less we can say lower than 1,000 cubic meter residential application, higher than 1,000 cubic meter non-residential, generally talking, commercial application. The commercial or non-residential application we are discussing about is to be included in the framework of the regulation 1253. We have the definition of two main typologies, the unidirectional ventilation units, defined here, and the bidirectional ventilation units. To simplify, one unit with one single fan blowing air inside the building, and one unit with two fans, one for the exhaust airflow and the other for the supply airflow. In case we have to design a unidirectional ventilation unit, we have some parameters to be respected. In case we design a bidirectional ventilation unit, there are some other parameters to be respected. These are the main definitions. Then the regulation gave the definition of what is a ventilation efficiency, of what is a heat recovery efficiency, of what is a heat recovery system. So we have all the definitions within. But these are, let's say, definitions that we usually integrate in our job, in our daily job. So it is mainly important to make this differentiation between bidirectional and unidirectional ventilation units, because it splits the calculation to be applied when we design an air handling unit. one way to calculate unidirectional ventilation unit and another way for the bidirectional ones. There are two steps. I use the 2016 step only to give an idea of what is going to change with the next year, because 2016 has gone, bye-bye. 2017 is almost done, so we are very near to the 2018. And with the 2018, the definitions and the parameters given by the norm will change and will be more and more drastic and stronger when we consider the air handling units we are designing. But generally talking, starting from 2016, they told us that the unit should, let's say, work with multi-speed motors or variable speed drives. So it is not required that the producers of the air handling units supply the air handling units with the frequency inverter on board, but it is required that somebody, probably the installer, will complete the unit with the inverter. So we, as producers, are asked to inform the final customers that they must apply a multi-speed drive or a variable speed drive like the inverters when they run their units. Unless this variable speed drive, the unit couldn't be considered as a eco-design unit according to what is defined in the regulations. All the bidirectional ventilation units must use heat recovery systems. So in the past, I don't know how you call them here in Greece, but we used to call them economizers or freeway mixing box. So we had three dampers, one for the exhaust, one for the fresh air, and one for the circulated air in between. This system is not allowed anymore. So every time we have an exhaust fan and a supply fan to work with, we must put an heat recovery system in between. This heat recovery system can be a wheel recovery system, a plated exchanger, or a runaround coil system. But if we look to what the regulation tells us, if we work with the common, let's say, heat recovery systems, we must use them with a bypass for the free cooling, so it is another thing that the norm forces us to apply. And they have also to respond to this kind of efficiency. They must give minimum 67% of efficiency if we talk about plated exchangers and wheel recuperators. If we talk about runaround coils, the value required by the norm is lower, 63, but the fact is that these values are already high. 5, 8 years ago, I used to select a plated exchanger with standard efficiency 50%, 40%, something like that. This was the common idea consultants and producers had to develop these recovery systems. Increasing the efficiency to 67% gave a boost to the size of these recovery systems and their capacity to recover energy. When we talk about the efficiency in the ventilation, because if we consider the efficiency in the heat recovery system, it increases the efficiency of the air handling unit because simply it helps us to recover more energy. When we talk about the ventilation efficiency, we say that the air handling units we install in our plants, in our buildings, should move the same airflow, but using a lower amount of electrical energy. So we must reduce pressure drops inside the units, we must size them in a larger way, we must use better fans, for example, better electrical motors with a higher electrical efficiency. But how can we say that these units are complying or not with the requirements given by the regulation? The regulation gives us some formulas to be applied in the calculations, and so they say that given the electrical capacity, the electrical power of the motor we install in the supply and the exhaust fan, we can apply this formula or take this value directly for the unidirectional ventilation units if the capacity of the electrical motor is lower or higher than 30 kilowatts. 30 kilowatts is quite big as a motor for an air handling unit. In industrial application, we can install also 45, but we are talking about industrial applications where we have air handling units for 80,000, 100,000 cubic meter each. So we are talking about, I don't know, automotive production plants where they build cars or whatever, to size a bit the idea of the typical application of such an air handling unit. When we are in installations where the electrical motor has a capacity lower than 30 kilowatt, the typical comfort application, building, offices and so on, we have a formula that calculates the minimum ventilation efficiency according to the capacity we apply for the electrical motor. The electrical motor is 3 kilowatts, okay, we put 3 kilowatts. It's 4.5 kilowatts, we put 4.5 kilowatts. And we calculate the efficiency in ventilation according to the capacity of the motor we install in the unit. This value is the limit value that the unit should respect. So we put the value inside, we take out a value. If our air handling unit has a ventilation efficiency better than this, the unit is okay. If we don't respect this limit, the unit is not okay and it is not eco-design. So we have to change something in order to achieve a better efficiency and then comply with the requirements given by the regulation. Unidirectional ventilation unit. If we go to bidirectional ventilation units, so we have supply and exhaust fan, and we must put a plated exchanger or a recovery wheel in between to recover energy, things become more complex. So we have this incredible list of formulas we must apply. We consider for the specific fan power, which is the reference value, specific fan power, so the electrical energy the fan uses to move 1 cubic meter. This is the idea. How many kilowatts we spend to move 1 cubic meter in our air handling unit. This is the idea of the specific fan power. They give formulas to calculate with recovery systems that are plated exchangers and recovery wheel, or for other recovery systems like runaround coils. They give these formulas. What I would like to focus on is not the formula itself. It is based on the calculation they did. The formula gives a parameter. Our efficiency, our specific fan power must respect this limit value. If we stay at a lower stage compared to this value, the unit is within the limits given by the norm. If our value is higher than the result of this calculation, the unit is out of the limits given by the regulation.
And the pressure drop, sorry, and the pressure drop refers only to the air handling unit, not to all the...
The pressure drop considers also the pressure drop on the ducts, because when you calculate the air handling unit, I do commonly this job every day, you put all the components inside the air handling unit, so you have the calculation of the total pressure drops. But then to size the motor and the fan, you have to say in the ducts, I will have 200 pascals, 300 pascals of pressure drop. To size the motor and the fan, you have to tell the software, the calculation software, 300, 400, because you know the pressure drop on the ducts. So you size the fan, you have the efficiency of the fan considering also the external static pressure, and you size the electrical motor also considering the external static pressure. But the fact is that if you have a duct with 400 pascal of pressure drop, there's nothing you can do with it. Maybe you can try to make the duct bigger, but me as a producer, I cannot discuss the value of the static pressure you measured in the duct. So this is a fixed value. Where should I work in order to better comply with the requirements? I should work on my product, so making the unit maybe larger, using a low pressure drop in the plated exchanger, in the coils, and so on. So the idea, and we will see moving also through the different points of the presentation, is that we have to work making units larger, because this is the way to reduce the internal pressure drops, and this helps us to make the unit respect the limit in terms of the specific fan power given by the norm. But the calculations are given for the air handling unit, but the pressure is considered also with the external static pressure. So the total amount is included. Given this idea, so we have to comply with the 67% in terms of efficiency for the recuperators. We have formulas to calculate limit values, and then our units should stay within these limit values. We must say that these formulas were valid for units produced after 2016 until the end of this year, more or less. What's happening for next year? They increased the efficiency to 73. For those who are used since 10 years ago to select plate heat exchangers at 50%, as we were commenting before, reaching 73 is an incredible jump. It makes the heat exchanger larger, and the cost of the air handling units also becomes higher because of this. But there's nothing to do with it. We must follow the line of reducing the consumption of electrical energy, and so the energy recovery systems are the only way to save energy as much as we can in order to, let's say, comply with these requirements. But this is creating some troubles to the air handling unit producers, because it's not so easy to find components giving this interesting level of efficiency. Then, what's going on? Runaround coils. They increased the required efficiency to 68%. Bye-bye runaround coils, because you should put 12, 14 rows in a coil in order to reach such an efficiency. But imagine how high could be the pressure drop of a 14, 16 rows coil installed inside an air handling unit. You work increasing the efficiency of the heat recovery system, and on the other side, you work against yourself, increasing the pressure drop inside the units. It's not a logic as a way to work. So what we prevent is that starting from January 2018, this system will be impossible, mostly impossible. The values, limit values, they corrected the formulas. So the coefficient we had here before in 2016 was 0.35, become 0.42, and 0.63 for capacities higher than 30 kilowatts. So we are increasing the minimum efficiency level required for the fans. So fans that were okay for tier 2016, because they were respecting the formulas given some years ago, will not respect these parameters in 2018. So we will look for better and better efficiency fans and motors inside the units. Same things happen for the specific fan power. Formulas are again changing, and so in this case the first parameter becomes from 1,600 to 1,700, the second from 1,300 to 1,400. I don't lose time to discuss each single point. The fact is that the regulation gives a limit value to be respected, which is more restrictive, and it will be harder in 2018 to reach these values. So if we build a unit large like this, in 2018 maybe it will have to be like this, because we must reduce the pressure drops inside and increase the efficiency of the system. Okay? Okay, this is, let's say, a general overview of what we have said just before. The specific fan power as a limit value, how they decided to calculate it, and if we go back a while, if we look to the formula, there are some parameters that are not specified yet. What are those E and F parameters given in the formula and considered by the European community to calculate the specific fan power? They gave two, let's say, general descriptions of what an air handling unit, unidirectional and bidirectional, should be. The unidirectional reference configuration has a fan and a filter. The bidirectional has two fans in a recovery system in between, and an F5 and F7 filter in between. If we compare our unit, we compare it to unidirectional reference configuration in that case, bidirectional reference configuration in this case. The ones who wrote the regulation simply said, okay, we said that in 2018 the minimum efficiency of a plate heat exchanger must be 73%. And if I install a 75, why should I be considered at the same level of somebody given 73? If I'm giving more than what the norm is requiring, I should be paid back a bit about this fact that I'm trying to push on the efficiency of the heat recovery system. So, in this case, we have for plate or wheel and for runaround coil two formulas that are comparing the value of the efficiency of the heat recovery system we are supplying to the base value given by the norm. So, if you have 70% in 2016 and the minimum is 67, you have 3 points of efficiency more than the norm is requiring. So they put the value in this formula and they gain a bonus to be used in the calculation. So if I use this bonus, which is 3% difference between the two, and I go back to the formula I see here, I can use it to make the specific fan power limit value easier. So if I don't use the bonus, the specific fan power limit value is hard, but if I put a very good plate heat exchanger, I can gain this bonus effect inside the formula and the specific fan power will become more acceptable. So when I work on the design of the air handling unit, I can also play with these parameters. Try to boost the efficiency of the plate heat exchanger or the recovery wheel, because it will be much better for us when we will select the fans, the compatibility with the limits given by the norm. Okay? Then somebody said, okay, pressure drops in the ducts are fixed, I should reduce the pressure drops inside the unit. Cancel all the filters, and the problem is solved. So, knowing that some producers are Italian, in the European Commission they said, no, pay attention. Filters should stay inside the handling units when calculating the pressure drops. Because we cannot look for very good efficiency and then create not comfortable situations inside the buildings. So removing the filters in order to decrease the efficiency, the pressure drop inside an air handling unit is not the way. So they said, if you have the complete configuration, so for unidirectional reference configuration you put at least one filter, and if you use an F5 and F7 filter minimum for the bidirectional reference configuration, you have a negative effect on the specific fan power you calculate, which is 0. So you don't have negative, let's say, influences on the specific fan power calculation. But if you don't install medium-sized filter, no fine filters, or no filters at all inside the unit, you have, in Italy we call it bonus malus with insurance in the car. Everything is okay, no problem, the price won't change, maybe it will be reduced. Something happens, you have a car incident, the year after you have an increase in the price. This is a malus. If you don't put the filters inside the air handling units, you have these parameters entering in the calculation of the specific fan power, making the specific fan power more problematic to be achieved. So better to put the filters and have a good quality and filtration in the air, instead of removing the filters and saying, well, I reduced the pressure drop, so the ventilation efficiency will be better. The ventilation efficiency of the fan will be better, but if we go back to the formula, you will have these extra factors creating troubles in the compliance with the specific fan power. So they studied the norm in order to force the producers to use all the required filters, to grant the comfort required for the different installations, but then they put also very restrictive formulas in order to push us to install larger plate heat exchangers, larger rotary wheels, combined with probably larger cross-flow sections in the air handling units in order to make the internal pressure drop lower. Going back to the past again, 10 years ago, I looked for years, who knows these tricks very well, the common idea of the air handling producers was consultants are asking for 70% of efficiency on the plate heat exchanger. No problem. I put the fresh air at 55 degrees. I put the exhaust air at -2. I put the supply air at 10,000 cubic meter and the exhaust air at 1,000 cubic meter. Unbalancing in this way the parameters of the calculation will create small plate heat exchangers with incredible efficiencies, because you are working in the very positive conditions. So if you play with the parameters and change them in order to obtain the efficiency you want, you can do whatever you want without modifying the structure of the unit. The norm is saying something different. It's not you who decides the operating parameters to be used when calculating 73 for 2018% and 67 for the units created before. You must put fresh air at fixed value 5 degrees and 25 for the exhaust temperature. And even though you should have in your installation an unbalanced operation, 10,000 cubic meter on the supply and 8,000 on the exhaust, even though the designing requires these parameters, the calculation should be at balanced conditions. So if you on the supply have 10,000 cubic meters, the calculation for the eco design will be with 10,000 cubic meters also on the exhaust. This doesn't mean that consultants are forced to do the calculation of their projects in this way. You can tell me, I want 10,000 on supply and 8,000 on the exhaust. But before giving the specification of the air handling unit, I will calculate the plate heat exchanger with these conditions. I will see if it is complying with the 73%, and then I will recalculate it with the conditions given by the consultants. So you know that the plate heat exchanger is complying with the requirements of the norm, and then you will have an idea of the performances of this system at your conditions. So it is common to see nowadays technical data sheets where you see plate heat exchangers with 74% in one row, and then 3 row just after in the line, 84, 84, 85. Why 2 different values? One is at fixed conditions for the eco design. If we comply with 73% minimum, that is a plate heat exchanger that we can use in our air handling unit. Then, knowing that we can use it for the eco design, we calculate it according to the requirements given by the consultants. But nobody is allowed anymore to play tricks on the parameters, increase a bit the supplier flow, or to change a bit the temperatures in order to show to the people the efficiency you want. Not allowed anymore. Given parameters for the eco design clearly, and the producers should show in their technical data sheets a table with a resume of the eco design parameters showing so that our efficiency is higher than 73, and then all the parameters calculated according to the consultant specifications. As you see, the norm gives also the formulas to calculate the specific fan power, and as we see, the specific fan power is linked to the ventilation efficiency of the fan, but also it is linked to the supply and exhaust line. But we have external pressure drops, internal pressure drops, and eventually the added pressure drops. If we think that within 3 years the customer will install an additional component, we should consider also this additional pressure drop when designing the unit. So we have additional pressure drops, external pressure drops, the ducts. So replying to your question, again we have, let's say, the indication from the norm that we should consider also the contribution from the ducts, and the internal pressure drops that is caused by all the components used inside the unit.
And, sorry, and when you show the results, you also show the consideration of the that you took into account when you made the calculations. I mean, the pressure drop at the ducts is something that depends on the design of the system.
Yeah.
That you don't know.
We don't know. We have to take it for granted, let's say.
At the customer, do you give him the information what pressure drop you assume that he will have in his ducts?
Yes, in the technical data sheets, and this is valid not only for our data sheets, it's typical for all producers, we split the total pressure drop, which is the internal and the external, in the internal pressure drop, so the components of the air handling unit, and what we call the available static pressure, which is which equals to the duct pressure drop. So you can see what is lost inside the unit and what is considered to be lost in the ducts. To be honest, in that case, we also say the calculation on the ducts is a responsibility of the consultants, and the installer should talk with the consultants to see if the ducts they are installing complying with the calculation they made, the design they made, and so on. From our side, we do the same. We compare with the installer, but also we talk with the consultants to see if the coil are giving the performances consultant wants, the fan are giving the performances the consultant wants, and so on. But it is clearly stated that from one side we have an internal pressure drop, and on the other side we reply to the consultant specification considering 400, 500, 200 Pascal as a static pressure available for the ducts. Okay? To resume a bit, a lot of persons during these years talking about this subject came to me saying, Cristiano, should we move from 2.5 cross-flow velocity on the coil to 2.0 or something like that? As you saw, regulation is not clear. So it is clear, but it is not so direct. There's not one parameter, I'm in or I'm out. There are many calculations to be done. And it is part of the producer, let's say, work. We must support the installer and the consultants doing these calculations for them. They are integrated in the calculation software of all the producers. For one reason mainly. It is not something concerning consultant's job. It is something concerning producer's job. Many consultants came to me saying, Cristiano, but if I write a letter stating that it is a special installation in an historical center in the center of Rome, I have no space where to install such a big air handling unit. Should I consider for this special case the opportunity to remove the limitations given by the eco-design and use the typical old way to design air handling units? No, it's like the catalytic discharge for the gases of the car. You cannot write a letter and say I don't want it because I don't need it, I think that I will use my car one day per year, so why use it? No, producers are forced by this law to respect the eco-design. So even though you have all the troubles of the world trying to fit the air handling unit in a very small space, I cannot tell you we can do whatever you want, we can do the air handling unit as you prefer. I must tell you this is what eco-design is requiring from my side, and I cannot put in the European market a unit out of this regulation. Okay? There are no exceptions, the regulation must be applied. But what are, generally talking, to give you some, let's say, easy information, the consequences of the application of this norm? According to our experience, the main subject is wheel and plate recuperators. There's no way. If you want to achieve the compliance with the eco-design, we must design larger plated exchanger or larger wheels in order to boost the efficiency and at the same time reduce the pressure drop. Because these systems are anyway the most important systems inside the unit. So not only efficiency, if they have a very high pressure drop, at the end I have a very good efficiency, but the ventilation efficiency will not be okay. So I must make them large to improve the efficiency, but also to reduce the pressure drop. After doing this job, I should do a very large selection for the coils, so cross-section larger than it was before. Use all the filters Also on the exhaust, sometimes they say me, Cristiano, put the filters only on the supply, I don't need a filter on the exhaust because the air is quite cleaned inside, so there's no need to protect so much the plate heat exchanger. But if you put the filter protecting on the exhaust side the heat exchanger, it will be much easier to respect the regulation than selecting the same unit without the filter on the exhaust side. And then fans. So on the fans, we must look for better efficiency systems. We moved from IE2 efficiency to IE3. Now there are the EC fans, brushless motors that are considered in the market equivalent to IE4 efficiency systems. So if we move to typical belt-driven fans to plug fans or EC fans, this will again help in increasing the efficiency of the system. So when you design a unit, focus on the plate heat exchanger and wheel heat exchanger, try to achieve the highest efficiency you can, and then try to accept the idea that if before the phase velocity on the coil was around 2.5, 2.6, nowadays it will be more around 2.0, 2.1, 2.2, it depends on the air handling unit and volumes you are handling with. Obviously, more efficiency will result in larger handling units and, honestly talking, also in higher prices in the market. But if we want to achieve such level of efficiency, there's something that has to be done, so there's no other way. We must change the mindset from the typical way we consider in designing the air handling units to this new approach, which is more focused on the efficiency and then takes in consideration the real consultant aims. I want the comfort, the temperature, and so on. Before efficiency, then we can adjust coils, filters, and the other things, making the unit, let's say, customized on your real needs. Okay? There are some points that are still unclear. The Danish Technological Institute had, from the European community, is in charge from the European community of developing a manual describing what the producer should do, describing the application of these units. But many producers started 2 years ago, and we are still placing questions to the European community because there are some points that are unclear. For example, they said units for swimming pools should be considered out of this norm because they have integrated heat pump systems inside. But if we do units with or without integrated heat pump systems, at this stage there's no clear position. So a typical air handling unit installed in a swimming pool should be out of the regulation, with or without heat pump. It seems that in future, only if it has heat pump integrated on board, should be out of the boundaries of this regulation, but nowadays it is still unclear. So about the boundaries, we already said. Replacement of all units combined with other air handling units. This is really a tough matter. I have to change my old air handling unit. In the roof, I have only 2 meters per 5 meters, and I must put everything inside because I don't want to, let's say, reduce the capacity of the air handling unit to provide comfort. I cannot cancel cold coils or hot coils or whatever. It must give the same performances that it gave in the past. Yes, but nowadays with the regulation, I must create it maybe 20 centimeters larger, 20 centimeters higher. I need, in the past perhaps they didn't install the plate heat exchanger, nowadays I must install it, and there's no space enough to place the new air handling unit in the same space where I had the old one. How should we behave? I cannot ask this hotel to dismantle everything and to create new ducts to place a new air handling unit somewhere else because in the roof they have not enough space. This point is still unclear. We asked how we should behave, and we are waiting for more information because they started saying ERP, no discussion. Now they are, let's say, realizing that in the real field problems are different, and they are taking in account that sometimes it's really difficult to force the selection in this way when you have restricted and limited spaces. There's an installation in Rome. We are near to complete this job. To make only an example, we said to our customer, please run, because if we provide the units within the limit of 2017, we respect Ecodesign 2016, and the units are a bit smaller. They want to install them in the roof, and there's no space in the roof, but those units fit the available space. If you wait 2 days more, and we must provide the units starting from January 2018, the units must comply with the 2018 efficiency, they must be larger, and they won't fit with the available space. So this is one point that technically we presented to the European community, because people have real problem at the end of the day. I'm not saying that we have, let's say, to avoid the norm every time, but in such situation, very complicated, some exceptions could be also accepted and considered. We are waiting for their answers for, let's say, these points that are still in discussion. I completed my presentation, so thank you, Cristiano. If there are any other questions, or otherwise I will leave the word to my colleague Alessio. Okay.
What about the electric consumption in the wheel? Does it go anywhere?
It is very, very limited, and the norm doesn't calculate it directly, because consider that normally an air handling unit has a 2.2, 3, 4.5 kilowatts per each fan. The electrical motor of the wheel usually ranges around 0.37, 0.25. It's a very, very small electrical motor. So probably in future they will start calculating the consumption of these components, but in that case I would suggest them, in case they ever ask me something, but I would suggest them to consider also consumption of other electrical components. If there are humidifiers, using a lot of electrical energy, and other ones that are using a small amount of energy. So in that case, they should, let's say, boost and increase the range of questions in terms of electrical energy consumption also to the other components we use in the air handling unit. But the wheel really uses a very, very small amount of energy.
It doesn't add up in the specific of the fan or something like that?
No,
the overall efficiency.
It is not included in the calculation.
Can I ask you about the water pressure drop on the coils?
Yeah.
And how does it affect in the consumption, the energy consumption of the unit?
This is one point. This is one point that integrates your observation. It seems from the regulation that me as a producer stop my calculation at the manifold of the coil, and then I forget what is outside. So I can do the best performance in my air handling unit, and then with a small air handling unit like this, you have a pump big like this because my pressure drops are too high. It's not good, obviously, but at this point of development, the norm doesn't give suggestions in terms of what pressure drop. This is part of our job as producers and your job as consultants, because if we are making proposals for better efficiency, we must take care of all the building to look for low pressure drop on the water side of the coil in order to also select pumps with the correct efficiency, using not a huge amount of electrical energy and so on. I hope, honestly, that in future some regulation will give instructions in order to, let's say, combine these informations also for the ducts. At this stage of the development, I must take for granted the calculation you did. But if in the end the ducts you calculated for 400 pascals are losing only 200 or are losing 500, all the verifications we did with these parameters means nothing, because nobody checked the side of the ducts. So a better integration of the different norms and regulations concerning the different points should lead to a global efficiency of the installation. We, as air handling unit producers, are giving, let's say, our contribution, respecting the specifications given by the European community with this regulation 1253, then the rest is part of your, let's say, competence, the capacity you have of understanding the installations, understanding the need of the customers, and doing things in order to make them work better and better year after year. So it is part of our duty more than something coming from the regulation. But I do agree with you, there should be something more complete from this point of view.
Thank you. Mr. Alessio?
Yes.
Eh?
Ready?
Yeah.
Okay. I leave the word to questions. Thank you.